Hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. We're going to do the first page of adding and subtracting rational expressions. So let's jump right in. If you are adding or subtracting fractions and they have the same denominator, then you don't have to do all the pre-steps that we'll have to do later on. If they're the same, like they are for the first few here, 8v, 8v, exactly the same. They can't be close, they have to be exactly the same. So they're both exactly 8v. All I have to do then is I add the tops. So I add u minus v plus 6u minus 3v. U minus v plus 6u minus 3v. And that's going to be over 8v. Now, before I put it over 8v, since I'm a little bit short on space on this one, I want to go ahead and combine the u's, because I have some like terms here, 7u, and combine the v's. Negative 1v minus 3v is minus 4v over 8v. And that's really as far as we can go if we keep it as one fraction. There are some v's, but not everything has a v in it. If everything had a v in it, then we could cancel out a v from everything. Or let's say if everything divided by 2 or something like that, then we could cancel that out and keep it as one fraction. But normally the point is to try to, make it into one fraction instead of the point being to, try to do all the things possible to try to cancel whatever. It's supposed to be simplified, not canceled necessarily. So canceling can simplify, but sometimes in order to cancel as much as you possibly can, you have to unsimplify. If we write it as two fractions, it would be a little bit unsimplified. So it's not really worth it to go ahead and explore that route. You can if you want, but let's go ahead and move on for right now. So denominators are the same again. I'm going to subtract the tops. Now this time it subtracts. I have to be careful. Earlier I didn't show that they were grouped, but they are grouped. I don't need to show that they're grouped if I'm adding, but if I'm subtracting, it's really important actually, at least for the second parentheses, because this negative belongs to all of that, which means really this is m minus 3n minus m minus 3n. Okay, so the m's cancel, but negative 3n minus 3n is negative 6n over 6m3n. And that actually simplifies a little bit too. Now that I've canceled out an entire term, and then I was able to combine what's left over, I just have a monomial, one thing, on the top, and another monomial, one more thing, on the bottom. So I can keep going. 6's cancel, and the n's cancel. Now there is a negative left over, and since there's no visible number, we have to put a 1 here. So negative 1 over m cubed. And there we go. So that's the answer to number 2. All right, number 3, moving on. So we'll change color a little bit each time as we go here. So the bottom does factor, but we don't need to factor it because they're the same terms. All right, so again, with the same term stuff, we could factor out something on the bottom, and we might in a second here, but right now we don't need to, not in order to add the fractions and combine them into one fraction. So 5 plus 5a plus 1. Well, 5 doesn't combine with 5a, but it does combine with 1, so this would be 5a plus 6. Then if we factored this, it could be helpful because it might cancel. Now, it's not going to cancel on number 3, but just in general, if the bottom doesn't have to be factored to combine, but it looks like it maybe could be factored, you might want to try to factor it anyways, because one of those factors might cancel with one of the factors on the top. Now, it won't on this one, but it will in the future. Okay, so I'm not going to show the factoring for this one. I'll save that for when we do need to actually factor it. All right, so next one. Again, with the denominators, they're the same again. Right, exactly the same. 10n squared plus 16n plus 6. So I add the tops up. 5 plus negative 6 would be minus 1. This one might actually factor a little bit. So the bottom has a factor of 2, it looks like. Everything has a factor of 2. So I could write that real quick as 2, and then in parentheses 5n squared plus 8n plus 3. And would that combine? Well, 5 times 3 would be 15, and then 5 plus 3 would be 8. So that would actually combine. And this already is a very difficult factoring problem. So let me show you how I would do this. What I would do is I would get two things that multiply to 15 and add to 8, which is just like regular factoring. So if you're not familiar with regular factoring, then this worksheet is a little bit too much too soon for you. Sorry, I'm just kind of telling it like it is. If you don't know regular factoring or extended factoring, and extended factoring is a little harder, so if you're a little shaky on that one, then bear with me, I'll explain this one here. But if you don't know regular factoring, meaning like trinomials, there's 3 terms, but there's no visible number in front of the squared term. It's just x squared plus or minus blah, 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 blah. Then go check out some of my other stuff on factoring. I have a ton of videos on factoring. I probably have more videos on factoring than I do on any other topic. So go check out some of that stuff. I'll have either a link in the description and or at the end. You can look at other videos in this series, which includes videos on factoring. And I have a whole series on factoring, regular trinomials. So go check out some of that stuff if you're not familiar with regular factoring. But this factoring is similar to regular factoring. I want to get two things that multiply to 15 and add to 8. Those happen to be 3 and 5. And then what I'm going to do is I'm going to write out the factors here. And then I'm going to keep simplifying. So I'm going to make a little bit of space right here. So I'm going to leave out that 2 as well, just for space reasons. So what I do then is the factors for 15 that add to 8 are 3 and 5. So what I do is I say, okay, well, I'm going to make 2 5n's. I'm going to do 5n plus 5. And I'm going to do 5n plus 3. 3 and 5, the ending terms, the plus 5 and the plus 3, those are the factors of 15 that also add to 8, the middle number. But I made an extra 5. I made an extra 5, this 5 right here. And the reason why this is great is because this is a little trick method that I call 2 truths and a lie. I have a video on that too. And here's what you do. You find the lie. The lie is the thing that has a greatest common factor. We already took out the greatest common factor. There should not be a greatest common factor, and yet there is right there. And now that's fully factored. I had a feeling that it might have been able to get an n plus 1. I did not end up getting an n plus 1 on both the top and the bottom, but I got pretty close there, so that's why I wanted to check that one, because it almost canceled, but not close enough, so that's actually the final answer. That's as far as you need to go there. And actually, you could have left it, oh, and there's a 2. Forgot about the 2. Left out that 2 there. You could have left it as it was, actually, for that one. It looked like something might have canceled for real on that one, so that's what I did there. All right, moving on to the next color as well. Again, we have the same denominator, right? So I'm not going to beat a dead horse here. We're just going to add the numerators. R plus R is 2R. 6 plus 1 is 7. And then I have 3R minus 6. There's no way these are going to have anything in common. This has a 3 in common, but it would be R minus 2 once I take out the 3, so that's not going to cancel with this. So we're done. Okay. Denominators are the same again here, but we're subtracting. So we'd have to distribute. It's going to be x minus x goes away. 2 minus 3 is negative 1, so I just have negative 1. And there's no need to even try to factor the bottom, because all I have left over on the top is a negative 1. So 2x squared plus 13x plus 20. And that's it, because there's just nothing to cancel with. There's not even a point to try to figure out if there's a factoring that we could do. All right, next up we have adjustment position here in the chair. Now we have unlike denominators. All right, so the day has finally arrived. We have unlike denominators. There's two different kinds of denominators that are not alike. There's this kind, which is basically the kind where, you know, they have nothing in common. X minus 1 and 4, nothing in common. When that happens, the fastest way to do it is this. Here's what you do. All right, so you go multiply these, 24, minus, keep the sign in the middle, multiply these, which is going to be 5x times x minus 1. And I didn't multiply anything out just yet because it's a little complicated there. I had to multiply 5x and the quantity x minus 1 and keep the sign in the middle, which was a minus, which I'm going to have to distribute. So let's clean that up first before I show you the denominator, but the denominator would be the last step. So this would be, so this is basically negative 5x. So I actually don't need a parentheses right there. So that's just minus 5x, and I don't need that extra parentheses. So I'm going to be distributing a negative 5x. So it's going to be 24 minus 5x squared plus 5x. All right, and then the last step. So you do bottom right times top left, step 1. Step 2, keep the sign in the middle. All right, so step 1 is right here. Bottom right times top left. Step 2, keep the sign in the middle. Step 3, bottom left times top right. And then step 4, you multiply the bottoms. 4x minus 1. I'm going to leave that factored. And I didn't leave the top factored because it wasn't really factored. When it's factored, there's no like minuses other than what's inside parentheses. So on the top, I had to FOIL it out. I had to distribute the 5x because it wasn't factored anymore. On the bottom, if I distribute the 4, it's not going to help anybody because it's already completely factored. There's no need. But on the top, I might be able to go a little further with that. I'd want to take out the negative to keep it a little bit more simple maybe, but basically, I mean, I'm going to want factors of 24 times 5, which is 120. Factors of 120, let's see. I'll write this over here, 120. And, oh, and it's going to be negative because it's 24 times negative 5x squared. So by the way, what I'm doing is, because I don't have a lot of space on this, I'm kind of seeing them in order in my head. So A, on the top part of number 7, A is negative 5, B is 5, and C is 24. You multiply A and C, and then you need factors of AC, negative 120, that are going to subtract in this case to give us 5. So the closest two numbers are 10 and 12. But that's a little bit too close because that would make positive 2. So we want to go a little bit further out than that. we can do 8. 8 will go in because 8 times 3 is 24. So that'd be 8 and 15. But that's going to be 7. So there aren't going to be any good factors. If it is factorable, then there aren't any good factors. And specifically, we're looking for a factor of x minus 1, because that's the only point to factoring is canceling. You don't just factor it to factor it. Remember, the goal is to simplify. The worksheet said simplify each expression. Simplify just means the least amount of numbers possible, basically. Right? With like some exceptions, like sometimes you might have like a term and it's got 4 things in it, and you could simplify it to 3, but then it's like, that's not really that big of a deal. But basically, if you can cancel something, you're getting rid of like 3 or 4 things at once. So that's why we try to cancel stuff. But anyways, it looks like it doesn't factor, so we're actually done. We're actually done there, right? So just 24 goes minus 5x squared plus 5x. Just nothing works. So kind of a bummer that we spent all that hard work and nothing happened. But hey, at least we know that we have the right answer. So I'm going to kind of box that in over there so we don't confuse it with this. This is 6 over 1. So in order for, that means the denominators don't have anything in common. So basically for our number 8, we're going to do the same thing we did on number 7. Multiply this, right? So that's going to be 6. And actually, I might need to go up here for this. Give myself some extra space. We'll see. So that's going to be 6 times 7x minus 5 times x plus 4. 6 times 7x minus 5 times x plus 4 minus, because there's a minus sign there. Let me erase because I kind of got rid of the minus sign there. So there's the minus sign. So we did that. Now we do this, which is just minus x plus 5. and then that would be over 1 times the denominator, which is just, the denominator. So let's try to clean up the top, because the denominator is just going to be the quantity 7x minus 5 and x plus 4. So let's see. If we foiled this out, this is going to be a bear to foil out, and I have a feeling it's not going to cancel with anything, but we got to check anyways, right? So 7x squared plus 28x minus 5x minus 20 minus x minus 5. So I'll go ahead and distribute that negative as well. Then we want to distribute that 6. We also want to combine the 28 and the 5, so let's do some of that at once here. 42x squared, 6 times 7. 28 minus 5 is 23. 23 times 6. I don't have that one memorized. Let's see. 18, 1, 12, 13, 138. Let's check here. 138. Yeah, that goes into 3. That's even. Okay. So, that'd be plus. Oh, and also we're going to subtract an x. So that's actually going to be plus 137. And then 6 times 20 is negative 120, minus 5, minus 125. Whew. Okay, that's quite the doozy there. Let's see. So 5, 6, 7, 8. That's really just a multiple of 5. Yeah, I really don't think this is going to go in. And just to save time, I think I'm going to cheat on a little bit on this one and see if it does. Because I have a feeling it doesn't. So you would just leave the top all like that, and then the bottom would just be 7x minus 5 and x plus 4. Let's find out. Let's find out. We're gonna peek ahead here. Yeah, okay. So 42, 137, minus 125. They multiplied it all out just like I did. 42, 137, 125. So, we know that we did everything right. It's just nothing's gonna factor. And this would have been really annoying to check. 42 times 125, and then we want factors of that give us 137. Yeah, no thanks. That's insane. And it's only number 8. Goodness gracious, people, calm down. All right, so we're just gonna call this one a day. That was crazy. That was a crazy problem. But that's what you would have to do if you wanted to check it without, doing what I did. Is you would have to try to see if you could factor the top. At that point, I'd probably just do quadratic formula, because it's like, yeah, you could check for factoring, but it'd be such a pain in the butt. So you might as well just do the quadratic formula at that point, because it's pretty much just as much work to do the quadratic formula as it would be to factor. And then you're not even guaranteed to have factors when you do factoring. Factoring is supposed to be the short version to completing the square. All right, moving on. Hopefully they're not all that crazy. Hopefully they don't, at least a little bit less, not expensive, but intense. A little bit less intense would be nice. All right, so remember, the denominators can either be the same, which we had for the first 6 problems, or they can be different in that they have nothing in common, or they could have a little bit in common, which is like a hybrid. And I'll have to show you what to do when that happens. But right now we still have it to where they have nothing in common, and it's plus this time. So I'm just going to do bottom right times top left. I'm going to go ahead and distribute as well. So 3x minus 24. Right, distributing the 3 into the x minus 8. Bottom right times top left plus bottom left times top right. I'm going to distribute that as well. 4x plus 28 over x plus 7 times x minus 8. But let's clean up this first. 7x plus 4. Okay, that's not going to go into anything that's on the bottom. So we're done. That's the answer. See, that wasn't nearly as bad as number 8. Okay. Now we have our first problem where the denominators are not the same, but they also do have something in common. So the first 4 to 6 or so, denominators were exactly the same. You just add the tops or subtract the tops, whatever. Boom, done. And then simplify, of course. Or the denominators have nothing in common. And then you do the method where you do bottom right times top left, bottom left times top right, bottoms multiplied for the denominator. Okay, which I've already demonstrated a few times. Now we have something where you could still do that method. So that method of bottom right times top left, keep the sign in the middle, bottom left times top right, all on the top side, and then on the bottom you have bottoms multiplied out. That method works even if the denominators are exactly the same. It'd be way overkill if the denominators were exactly the same, because you don't need to do any of that. But that method works on anything. It's like the quadratic formula. like the catch-all. If they do have something in common, then basically what you do is you would like find the least common multiple, basically. So if you just have two things, the least common multiple is actually not that bad. What you do is if you have two things, let's call these two things A and B. So I'm going to come off to the side a little bit here. So we have A and we have B. And A and B represent like anything. It could be a monomial, it could be a binomial, it could be anything. So basically, if we're trying to figure out what the least common multiple of two things is, if it's just two things, all you really have to do is multiply them and then divide by their greatest common factor. Greatest common factor. And that will work all the time if you only have two things. Now, if you have more than two things, this method doesn't work, but anytime you're just adding or subtracting two things at a time, if you want the least common multiple, it's always going to be the product, multiply the two things, and then divide by the GCF. So what is the GCF of these denominators? Well, it's 2, because this whole binomial divides by 2, and that is a 2. So the GCF is 2. And if I multiply them and then divide by 2, I'm basically just saying, well, 4v squared plus 4v then is the GCF. So is the least common multiple. So what I want to do then is I want to multiply 2 by something to get it to equal this. So if you want to, if you have trouble visualizing that, you could always divide that by 2. And then basically that would be what you need to multiply your 2 by. So that's one way to think about it as well. So if we divide this by 2, I'd get 2v squared plus 2v. Right, so 2v squared plus 2v. And like I said, this way, the hybrid method, it is faster, but it's a little harder to pick up. This is like the hardest way to add and subtract fractions, is to do it this way with the least common multiple. It is the fastest way if they have something in common. So you do want to learn it eventually. But if that seemed a little off, I mean, just watch as I do some more of these, and maybe it'll start to click a little more. But then also remember, you always have that backup: bottom right times top left, bottom left times top right. Okay, so we're going to multiply by 2v squared plus 2v, and that'll make the denominators equal to each other, because then the bottom will be 4v squared plus 4v. Okay. So I'm going to go ahead and distribute as well. So this is going to be 3 minus 7 times 2 is 14, so 14v squared. Oh, and minus again, actually, because I'm going to be distributing a negative 7. So minus 14v over. I'm going to want to factor the bottom just in case I need to factor the top. I don't think I need to factor the top, actually. But, so I guess you don't really need to, but I guess you can go ahead and write it like that then. So 4v squared plus 4v. You could factor that out, though. You could factor out a 4 and a v, and then you would just have v plus 1 left over. But it looks like the top isn't going to factor, so we don't have to worry about it. And just to check, so it would be 14 times 3. So that's going to be 42. Oh, wait, 6 times 7. But that would be 14. I was just thinking 6 times 7 because that would subtract a 1, but we're not trying to get it to 1 because it would be v plus 1, not 1. Okay, sorry, overthinking. Yeah, that's not gonna... It's 42, 2 and 21, 3 and 14, obviously, 4, 5, 6, 6 and 7. But none of that's going to make 14, so yeah, it's not going to have nice factors. If it does factor at all, it's not going to factor into anything that's useful. So we're done there. All right, we're on the last 4 now. Now there's a whole nother page to this, but I'm only going to do 1 page at a time. This one's already long enough as it is, just doing 1 page at a time, so I'm going to do the second part next time. These two don't have anything in common because 8 does not divide by 3, so we're going to do the standard crisscross applesauce. 7 times 12, I believe, is 94? Is that right? No, 84. 84. 84x. minus 56. Then 3 times 8 is 24. Ooh, that was thunder. Yeah, 84. Okay. And then we can simplify. We'll go ahead and simplify that. 84x minus, that's going to be 5, 6, 7, 8 over, we multiply the bottoms. Except we don't need to with the bottom because it's going to be fully factored if we don't multiply them out. We just leave it like that. All right, 84 and 80. Is that going to simplify down? It might actually. I think it will. 84 we know is 7 times 12. So, oh no wait, but we're trying, oh, the biggest thing we could take out would be a 4 though. So never mind. The biggest thing we could take out is a 4, and then that would be 21 minus 20. So actually, never mind. That's as far as we can go. I was thinking maybe, but no. That's it. That's as far as we can go. All right. These two don't have anything in common, so crisscross applesauce. That's going to be 5 times 2n plus 6. That's 10n plus 30. 4n times n plus 5 is going to be 4n squared plus 20n. Okie dokie. So then we have 4n squared. And then we have plus 30n plus 30. And that factors a little bit. Let's see. So take out a 2. 2n squared plus 15n plus 15. 2 times 15 is 30. 30 is 3 and 10, 5 and 6, 2 and 15. None of that adds to 15 though, so I think we're good to go. I don't think that factors, at least not into anything nice. Let's check what's on me. 30. I think I checked everything. 2 and 15, 3 and 10, 4, 5, 5 and what was it? 5 and oh my gosh, why am I blanking? Oh, 5 and 15. No, 5 and 6. There we go. 5 and 6. Yeah, none of that gives us 15, so the factors are not going to be nice. And by not nice, I mean they're not going to be rational. And so since on the bottom we have rational stuff, we don't have to worry about it. Oh, except we do have a 2. So we can factor out that 2 from 2n plus 6, and then that would be n plus 3. There we go. N plus 5, and then the 2's cancel, and then what's left over is the answer there, since that top doesn't factor at all. Okay, now we're on to the last one here. Last set, I should say. Again, they don't have anything in common, so we're going to crisscross applesauce. We do 4x squared plus 6x plus 30x squared plus 24x. Whew, okay. So then 4 and 30 make 34. 6 and 24 make 30. So we can factor out a 2x there. I'm going to just go ahead and factor it out because I have a feeling that something's going to cancel here. 17x plus 15. Okay. Well, yeah, I guess not, because that's all that happens there. So 2 and 2, that's 4x squared. Let's see. And then that's 30x squared. So 34x squared, yeah. And then we have the 6x and the 24x make 30x. I'm just checking because it seems like, we're on the last 2 of this page. I guess because in my mind it's like these are the last 2 problems that I'm doing, so I'm expecting them to be like insanely hard, but we're actually only halfway through the worksheet, so maybe that's what it was. As I was like just expecting something to happen. But it looks like we're good actually. So the bottom, nothing really factors out from either of those binomials, so we would just leave it like that, and then that's it, because nothing cancels. So that's it. It's a big disappointment. Nothing canceled out at all. We could have just left it how it was. Okay, so now, so these both have an x in common. So this, we could do the crisscross applesauce. You can always do that. But since they both have an x, then we really just need to multiply them so that they get to a least common multiple. Another way to think about least common multiple is to write them out. So we would say, write them out fully factored, that is. So 3x. If I factor out a 3 and an x, I would have x plus 4 left over. and then on the other one I have a 2 and an x. So they both have an x. So basically, you take all the factors of the first thing. It doesn't matter which one's the first thing. So 2 and x. And then you take all the factors of the next thing, unless there's a repeated factor. So times 3, not times x, because we already had an x, and we don't have an x plus 4 yet. So boom, there's the LCM. That's one way to do LCM. That works no matter how many terms you have. The other way, multiplying them and then dividing them by the GCF, that only works for 2 terms. What I just did works for any amount of terms. So that's the LCM. And then we just multiply up to the LCM. So 3x squared plus 12x. Well, basically we had all of that except for the 2. So we just multiply this by 2. 2, 2. Put a little divider there. And then over here, we were missing a 3 and an x plus 4. So 3, 3, x plus 4, x plus 4. And that will get us to have the same denominators, which means we can now add up the numerator, so it's going to be 4 plus 3 times 8 is 24. 24 times x is 24x. 24 times 4, you just double it twice, so 48, and then 96. Plus 96. And that's it for that. So then we add those up. So 24x plus 100. And then we're over, let's see. So 2x and a 3 and an x plus 4. So all of that together, but actually, you know what? Let's leave it factored because we might be able to get a factor out of this. So 2 and well, actually 2 and 3. Let's leave those together. So 2 and 3 is 6. 2 and 3 is 6. So 6x and x plus 4. And then let's see if the top factors out. So it looks like we can factor out a 4, and that's probably the largest thing because they both don't go into 8 and 100 doesn't go into 3. So we can take out a 4, and we'd have 6x plus 25. And then over here we have 6x, x plus 4. Boom, boom, 2, 3. So then that's it. That's as far as we can go. So it'd be 2. We can go ahead and redistribute if you want to, but you don't really have to. I'm going to just so it looks a little nicer. And it is kind of more simplified to go ahead and redistribute. So 3x squared, and then 3x times 4 is 12x. And that's it for that one. Okay, that one was kind of like a final question, because it did take a while to do. There wasn't a lot of real tricky stuff other than at the beginning, because you have that hybrid method that you could do. But you could always fall back to the whole like crisscross applesauce thing. I don't know why I decided to call it that, but hey, it is what it is. So that is it for half of this video. If you want to see the other half and you're watching it, now, which is like August 9th of 2022, and you're watching it like right after I put this out, then congratulations. But then also, it'll be another week before I make the second half to this, where I do the other half right here. But if you are just trying to look for the answers, you could always just Google the worksheet, and it'll pop right up. And it'll have all this stuff in here for you. You could also go grab some of these worksheets on my website, Myers Mathematics, and that link is in the description below, myersmathematics.com, where I have a ton of stuff like this. All these worksheets will be in there. And then for this whole series, like all the algebra worksheets will all be in there. And then also, I have a guide called 5 Math Mistakes Everyone Makes and How to Avoid Them. So go check that out as well, and I'll see you in another video real soon.